In this problem, we have to calculate the final pressure, the composition of mixture and partial pressures of components at final conditions. So the number of moles are equal to PV hour ZRT. First find for methane. For methane, so N is equal to, here P pressure is given, which is 1000 psi, volume is V tank, divided by Z for methane is 0.938 at 1000 pressure and 140 Fahrenheit temperature. 8 R is 10.732 and temperature is 40 140 plus 460 to convert it into Kelvin. So N for methane is 0.156 V tank. Now find for ethane. And here P is 500 psia, 500 into V tank, divided by, here Z for ethane is 0.792 into R, which is 10.732. To convert temperature from Fahrenheit to Kelvin, we will add 460. So N for ethane is equal to 0.098 V tank. Now we will find the total number of moles, which is equal to NTNM plus NE. Here Nm is 1656, 0.1656 V tank plus 0.098 V tank. So NT is 0.2636 V tank. Now we have to find mole fraction, mole fraction. So mole fraction for methane is number of moles of methane 0.1656 V tank divided by the total number of moles. So the mole fraction for methane is 0.628. Now calculate for ethane, which is number of moles of ethane 0.0980 V tank divided by total number of 0.2636 V tank. So mole fraction for ethane we have is 0.372. Here we have table. So from mole fraction we can say that TVC we have 419.8 degree and pressure PC we have 681.3 psi. So since pressure is needed to calculate Z and Z is needed to calculate pressure, so then we will be calculate this by the heat trial and error method. So where We have pressure 750 psia, volume is 2V tank, number of moles 0.2636 V tank, and T2 is 600 R, so and TPR is 60 divided by 1419.8, 1.429, and PPR is 750 divided by 681.3, 1.1. Now calculate PVZNRT. So we have to calculate pressure P. Pressure P is equal to Z 0.888, N is 0.2636 V tank into R, which is 10.732, and temperature is 600 divided by V tank, which is 2V tank. So the total pressure we have is 753.6 psia.